Today we're going to talk about combining like terms. To get started, let's review the different parts of an algebraic expression. Remember, an algebraic expression is an expression that has letters in it or variables and also sometimes numbers. First of all, variable terms are terms that have letters in them or variables. In the variable terms, we refer to the number that's in front of the variable as the coefficient. And the last terminology you need to remember is what a constant term is. A constant term is just a term that is just a plain number. So if you look at the expression that's on this screen right here, some variable terms we have are 7x. This is a negative 5x. We need to make sure we include that negative sign that's there. And we have a positive 4x. Those would be variable terms. The coefficients would be 7, negative 5, and positive 4. The constant terms are just the plain numbers. So we have a positive 3, a positive 8, and a negative 1. Notice how I included that negative sign on my term. Some of you may say, is it a subtraction sign or is it a negative sign? And remember, we're trying to get away from thinking about it as a subtraction sign. That sign is considered a negative sign in front of the number. All right, so let's continue. Today we're going to focus on like terms. Like terms are terms in an algebra expression that have the same letter or group of letters, and they have to have the exact same exponent on them. Another type of like term are our constant terms or our numbers. And so today we're going to work on combining them. So looking at the first expression here, 7x plus 3 minus 5x plus 8 plus 4x minus 1. Let's look at what terms might be considered like terms. So first of all, we look for things that have the exact same variable. They have to be identical with the same exponents and everything. So I see a 7x, a negative 5x, and a positive 4x. I'm going to combine those together. The way that I combine them is I add the coefficients, or the numbers in front. So I'm going to add the 7 plus the negative 5 plus the positive 4. And so 7 plus negative 5 plus positive 4 would give me 6. So I have 6 x's. You can think about it like this. If x stood for x-rays, you'd have 7 x-rays, you're taking away 5 x-rays, and then you're adding 4 more. That would be a total of 6. So we can combine those terms because they are like terms with the same variable. We can also combine our constants or our plain numbers. So here I have a positive 3, a positive 8, and a negative 1. And so when you add 3 plus 8, that's 11. 11 minus 1 is 10. And so we have just combined like terms in our algebraic expression. That expression simplifies down to 6x plus 10. On your handout, I'm going to work the odd examples, and then I would like you to hit pause and take some time and work the even examples to see if you understand it and are getting the right answers. So let's get started with problem number 1. We are going to combine 3x plus 6x. So those are considered like terms. They have the same variable, which is x. So how do I add them? I add the numbers in front, the coefficients. 3x plus 6x would be 9x. Imagine having 3 x's written down and then another 6. How many do we have all together? That would be 9. So think about it like that. Now let's look at number 3. Problem number 3, I not only have variables, but I also have a number or a constant. So what we can do is we can combine the like terms. So I can combine the m's with the m's, and I'm going to have the number. You never combine a plain number with the variable. They're two separate things. So what I like to do is I like to underline things that I know are like terms. So I have a 7m and a negative 5m. I can combine them. That gives me 2 m's. Then I have the constant, negative 6 right here. Again, I can't combine that with the m's, so I just bring it down. And so my answer is 2m minus 6. Let's look at number 5. I see p's and I see numbers. So my like terms that I can combine are the 7p, and this is a negative 9p. Notice how I included that negative sign in front of the 9. When I add a 7 and a negative 9, that gives me a negative 2p. Now I can combine my numbers, and I like to use some underlining to kind of show which terms are like terms. So I'm going to underline this twice. So I have a negative 1 and a positive 5. And when I add a negative 1 and a positive 5, that is 4. So I have a negative 2p plus 4. Let's look at one more example. I'm looking at all the different terms in number 7. I see x's, I see y's. So I have two different types of terms that I can combine. I can combine the x's with the x's and the y's with the y's. So let's do some underlining. I have a 5x, a negative x, and a 3x. Those are going to be some like terms. Now, I know that I add the like terms by adding the numbers in front or adding the coefficients. What coefficient is in front of the negative x? What number is there that we just don't write because we like to be a little bit lazy in math? If you said negative 1, then you're right. So I have a 5x and a negative 1x. That's 4x. 4x plus 3x is 7x's. That's how you do that. So if you just see a symbol and not a number in front of the variable, there's a 1 there. Now I'm going to go ahead and I'm going to combine my y's. I can only combine y's with y's. They have to be identical variables for you to combine them. So I'm going to add a 7y and a 2y, and that gives me 9y's. So my answer is 7x plus 9y. Now, will you please take a minute, hit pause, do numbers 2, 4, 6, and 8, and then you can hit play when you are ready to check your answers. All right, let's see how you did. Please check your answers to 2, 4, 6, and 8. A couple things I'd like to point out. Problem number 2. When you subtract the coefficients 9 minus 10, you get a negative 1. You can write your answer as negative 1a, but usually in math class we like to take shortcuts and we don't write that negative 1. And so when you look in math textbooks, you're going to see it a little bit different. So I highlighted how you're going to see it in a math textbook. It's just going to say negative a, and that means negative 1a. Another thing I want to point out is in problem number 4, I'd like to point out the order that I wrote this in. It starts off with a number, and then you have your variable, 9 minus 6w, and then plus 5. So some of you may have written 14 minus 6w. That answer is okay, but in our math textbooks, the proper form to write an algebraic expression is to put all of the variable terms first, and then you put the constants at the end. So I'd like you to get in the habit of doing that. The other examples are pretty straightforward. Number 6, I combined the h's with the h's and the constants with the constants. And number 8, I combined the a's with the a's and the 2b and the 10b to get the b terms. All right, if you have any questions, circle them and ask later. Now let's look at some that are a little bit trickier that have exponents. If you remember at the beginning we talked about combining like terms, I said like terms have the same variable or group of variables and they have to have the exact same exponent for them to be like terms. So let's look at a couple examples here. I will work the odd ones and then I'm going to pause it and have you work the even ones. Be careful when you combine like terms. We're not changing the exponents. We are just adding the coefficients, which are again are the numbers in front. So let's start with number 9. Number 9 says 5x squared plus 7x squared. So think about it. If I had 5x squareds in front of you and I gave you 7 more, how many would you have? You add the coefficients in front. These are like terms. So the answer is 12x squareds. Number 11, I have all these are like terms. I have an 8c cubed, a negative 7, and a positive 16. Since they're all c cubes, which means they have the same variable and the same exponent, I just add the coefficients in front. So 8 and negative 7 is 1, and 1 plus 16 is 17. And notice I'm not going to change my variable or the exponent. I'm just going to keep them the same. And excuse my handwriting. It's hard to write with this little pen. So it should be 17c cubed. Finally, problem number 13 here. This one's a little bit trickier, but if you notice, these are all a squared b's for the first term and the last term. Again, they have the exact same identical variables with exponents. They have to be identical. And if they are, then you can combine them by adding the coefficients. So I'm going to add the -4 and the 10 in front of those a squared b's. That gives me 6a squared b's. Notice again, I'm not changing my variables. I'm keeping them exactly the same. I'm just adding the numbers in front. So what do I do with this -7 or this +7 right here? It's a constant. There's no other constants to combine it with, so I just bring it down. And so my answer is 6a squared b plus 7. Now please try numbers 10, 12, and 14. Hit play when you are ready. Okay, now you can check your answer to numbers 10, 12, and 14 and see how you did. I do think it's helpful if you underline terms that are like terms. So if you look at one like number 12, I have k squared terms, so I can combine them. I have k terms, I can combine them, and then I have a constant. If you'd like, get out colored pencils and use that to help you also. If you have any questions on these, please circle them and make sure you ask. Also, looking at number 14, I have this x squared, but there's no other x squareds to combine it with, so I just bring it down. I have the 4y squared, but there's no other y squared, so I just brought it down. But then I have this group of variables that are identical, the xy, so I can combine them. Again, 2 and -7 would give me that -5. All right, let's move on. We're going to skip the bottom two problems and just move on to our final topic. Let's apply this. We have some geometric figures here. Here we see a triangle, and we're going to try to find the perimeter of the triangle. What does perimeter mean? If you said the distance around an object, then you are right. So what I'm going to do in problem number 17 is I'm going to find the distance around, or the perimeter, by adding up all three sides. So I'm going to add the 2x plus 1, that's this side here. I'm going to add the 3x, that's this side here. And then I'm going to add the x side. Now I can apply what I've learned about combining like terms. I have a lot of x terms here. I have a 2x, a 3x, and an x. And remember, that is a 1x. I can combine them by adding the coefficients. So I'm going to add 2 plus 3 is 5, plus 1 is 6. So I have 6 x's. And then the constant term here, this 1, I'm just going to bring it down because I have no other constants to combine it with. So the perimeter of this triangle is 6x plus 1. Now hit pause and try number 18 and hit play when you are ready. All right, let's see how you did for problem number 18. Your final answer should be 4a plus 4ab plus 16. Notice I wrote down all three sides added together. I combined all of my a terms, which I've underlined once. I combined my constants, 17 and -1. I underlined them twice. And my ab term, I had no other terms that had both ab in it, and so I just brought that term straight down. And again, remember that I talked about we put the constant terms, the plain numbers, always at the very end. Let's look at one more example before we wrap up this video. My last example is something similar to this one. Let me get back. And it is problem number 19. Again, you're asked to find the perimeter of this rectangle. So where some of you are going to get tricked up by this problem is if you look at the sides, only 2 of the sides are labeled. Remember, perimeter is the distance all the way around. So what I would recommend doing is labeling all your sides before you begin. Think about, what do we know about the sides in a triangle? If you said that the opposite sides have the same length, they're exactly the same, then you're right. So if this side here is y plus 2, this side over here is also y plus 2. And that the top is 3y minus 5, the bottom is 3y minus 5. Now I can apply my combining like terms to finding the perimeter. So if I add up all the y's, I had 3y, another y, that's 4y. Remember, there's a 1 here, we just don't write it. Plus another 3y and a 1y, that'd be another 4y. So that is a total of 8 y's. Now I can add up my constants, and be careful, this is a -5, a positive 2, and another -5 and a positive 2. And when I add all that up, I will get a negative 6. So the answer would be 8y minus 6.